I was very happy about two things this morning. So Stephen did a great overview on big data. So I had to throw out about 5 slides, which was good. Then came Andy with his more critical observations on big data. So I removed another 3 slides. I'm very happy to not be not speaker number 10 or so. So the second one is about the CIA. I want to assure Stephen that CIA wouldn't follow me, really. Couldn't, because I have a cast. So I walk very differently, which is, I thought, a nice trick to overcome this level of control. So in the near future, I will change from left to right and so on. So it's okay. So big data, and it really nicely follows the first 2 speakers, I hope, by the way, because this is now one example. It's a proof of concept that a very large European project is implementing currently what they call CDI, Collaborative Data Infrastructure. And that's what the talk is all about. So I won't talk about the Uber cloud. Some of you expected that, I guess. But there is still a presentation about Uber cloud tomorrow by Dennis Nagy. So you didn't get the prize, but yeah, okay. So that is tomorrow, and he will lift some of the secrets which are kind of in the cloud still. So this one is about big data in science. That's the only data slide about data trends which I left in after Stephen's talk. And I don't have to go into the details. I mean, Stephen brought it all. We see strong accelerations in this space. It is exponential growth, not only, I mean, of the amount of data we are coping with, but also its complexity, structured, unstructured. And it is not only how to store it, but it is how to maintain it, how to conserve it, and how to find it back again, how to use meta catalogs, and then finally to get to the level Andy mentioned, which is information, which is knowledge. That is really what big data is about. That's our goal. And one of the first steps into this direction is, again, one of those European Commission, Brussels-funded projects. It's about a $20 million project. And some of you remember that last time I talked, that was about DISA, the Distributed European Infrastructure for Supercomputing Applications, which is the predecessor. These guys in DISA discovered that, hey, now that we have these 16 supercomputer centers in Europe, which are all connected into this one distributed but virtually together, tied together infrastructure, which in a sudden produced a lot of more data. In just a distributed virtual environment with so many powerful, almost petaflop, beyond petaflop computing resources, they were drowned in data. And it was almost straightforward to apply for a next round, which completely focuses on data, or to be more honest, on this convergence of data, big data, and high-performance computing. So it's still, what we heard previously, it is still science, it is big science, it's all the big, so it fits nicely into the conference. I didn't make it up. So it is really big data coming from the big sciences using big computers. It's all now in the petaflop range on that side, and also already in the petabyte range on the tackling with the data and producing results. So big data. How to ensure interoperability with all that different stuff. So what we see in Europe, there are billions of dollars spent to support the individual vertical, as I want to say it, communities in the very different areas, not only in engineering simulation or in the big sciences, you name it, also in the languages and many more. We know these communities, historically, they started in themselves, like silos. But over time, they started to overlapping each other. And the unfortunate thing which you see then is they partially use or want to use the same data, but they have very different approaches, methodologies, and things, infrastructures to store them and to reuse them. So now what we want to do is we want to find a common denominator first and help the communities to get more structured, to get more standardized, and ideally using one infrastructure. I mean, that's certainly a dream, but you will see how far DISA, and the successor of DISA, EUDAT, will move forward. So we have these basically horizontal layers which are all across the different verticals of HPC, big data, collaboration, communication, etc., vertical communities. So you have very community-specific data, which stay forever in this community and move this community forward. But then you have services, again, as I said, some are overlapping. So services left and right in 2, 3, 4, 5 communities, which could be used and standardized for all of them. And finally, then you have these basic services. And I will get to that. EUDAT currently has identified 6 of them because they send a list of requirements to all these communities and say, hey, so what are your services looking like? Which services do you provide to your specific community? And EUDAT found out, and no secret about that, I mean, very, very straightforward, that there are about 6 of these services. And EUDAT is now putting these 6 core services at the bottom of their service infrastructure. We will see that. So this is basically a high-level architecture and workflow, as I would say, how data is moving, from the data creation down to the different levels of services and up again to make it information, to make it knowledge, and to make it shareable, make it that people collaborate, even between, not only within, but even between and among the different communities. Just because of the complexity, just because I don't see anymore really one community which will be just that one community in 5 years or so, because of multidisciplinary approaches and the likes, that some of these communities are getting closer together, like very simple math, 1 + 1 is 3. Yeah, you know what I mean. So, as I already said, EUDAT is concentrating on this lower level for now. However, in the next approach, they will provide tools so that everybody within these communities can work and also jointly work on this more specific layer of services, community-specific, team, so group, vertical-specific. So let's quickly summarize the project. We are now exactly half, so 18 months into the project. As I said, it's about $20 million, and it is one of the big European projects which are supported by the European Commission in Brussels. And so there are mainly 3 objectives. One is it has to be cost efficient and high quality infrastructure, the collaborative data infrastructure, CDI. And it has to meet the user's needs. We know how to do that these days. I mean, you talk a lot to your customers, meaning to your end users. You do a kind of a summary of all that, and then you get to what I call the common denominator, which then everybody can immediately benefit of. Certainly, then you enhance it over time. I can imagine that there will be a EUDAT 2, because there was a DISA 2, because there was an EGI 2. So the good and large projects, they will get at least 2, if not even 3 rounds of funding. Yeah. And it's always basically the same amount. Okay, so these are the current partners. I won't read them. You know quite a few. I think you just stare at it for a second, and then the aha effect is coming over you. Oh, yeah, okay, these guys again, Jülich. No, not again, Jülich. Yes. But these are the drivers in Europe, really. Yeah? There is no exception. These are all the leading institutions you have. And there are many more, okay, but the money is not sufficient for funding everybody else. What EUDAT is doing is currently within this group of 16 plus 5, so the 5 are the end-user communities, but it is of value, hopefully, for 100, 200 communities over time. So for now, EUDAT concentrated to invite these 5 end-user communities. So it is EPOS, Clarin, Ines, LifeWatch, and the virtual physiological human. You have certainly heard of 1 or 2 of them, maybe. Some of them are really, in a different area, still dealing with HPC, like the common language resource, but still far away from usually what most of us do, which we also could define as, I like the brief discussion this morning, more technical computing than HPC. So that's where we go these days. We broaden it up to all technical computing, even embracing the powerful workstations, which were the craze just 10, 15 years ago, as we know. Right? Okay, so I will quickly run through that. There is a lot more behind. I'm not, for example, a plate observation specialist, so, the most interesting comments are usually, who is that? Oh, David. I forget to switch off Skype. I hate that. It's a very useful tool. I spend 2 hours on average a day on that one, but okay. So you will see more because I'm too lazy to switch it off now. I think I know how to do that. There is a little switch. I don't have to do it by software. So who are the hardware? There was one hardware guy. Oh, no, outside. Yeah, in the booth. Yeah, he said he is our hardware guy. So hopefully nothing crashes. Yeah, so this hardware button works. Oh, now Intel comes up. Okay. Thank you very much, Stephen. Good, but this was the confirmation. Okay, sorry for this little excursus. So we have here this research infrastructure for data and for the observatories on earthquake, volcano surface dynamics, and tectonics. So these are all very, very advanced communities. They are here for 10 to 20 years at least and using very powerful systems. They are using, what you see here, these sensors, hundreds and thousands of sensors, which create the big data, which these communities have to cope with. Yeah, so it's about, there's no secret here. It's almost valuable. So these 4 bullets here, they are almost valuable for any community. It's about sensors, whatever these sensors are. A supercomputer is a very big sensor, in my humble opinion. So statistics, metadata, architecture, reference architecture, and so on. So the other one, which is a little bit farther away from what most of us do here, it is about a collaborative effort to create, coordinate, and make language resources and technology available for this language community. This is a huge one in Europe, because we have a little bit more languages than you guys here have. And also the history, which is, I love to go into, where a specific word is coming from over the hundreds of years. Very exciting, because like Germany is sitting right in the middle of a language melting pot from France, Roman, from the north, from England, even from languages which are not really familiar to us, which is Finnish or Hungarian, and so it's all kind of provided words to our language. And not to forget what we call old German. I mean, what people 2,000 years ago were talking. So my name, for example, is an old German name, Wolfgang. I'm walking like a wolf, as you have seen with my clumsy foot these days. Okay, so sorry for that. Yeah, so we said that. Very nice one. Then we have INES, which is climate modeling. I mean, these are these interesting approaches. So there are 20 of these centers. SIM data model using the CDI at the German Climate Center in Hamburg, and METADATA and so on. So I think that's, we all. This is a very interesting one because it is relatively new. And it attracts more and more members of the community and also more and more money. This is, building a biomedical modeling and simulation of our human body. The aim is to improve our ability to predict, diagnose, and treat diseases, and will have certainly a dramatic impact on the future of healthcare, the pharmaceutical and medical device industry. I mean, we also see this in the UberCloud experiment in a sudden. We have 3 teams of the 60 we have now are just dealing with medical devices, even with micro devices, which you cannot put into a wind tunnel or something else, but which you have to simulate. And these guys, they use CDADAPCO, they use ANSYS, and for stress and strain, they use Abacus. So all these great companies, these software companies, are part of this experiment as well, and Dennis will mention that. But this is exactly this area here. Yeah. We get more and more of these medical devices, and we need them in an optimized form. So one of these teams was stent optimization, which the doctor can put into your vein so that it doesn't clog anymore, and it has to be flexible. It has to move with you somehow, with your bloodstream and so on. Great stuff. I mean, very, very exciting. LifeWatch, biodiversity, data observatories, basically the same direction. Operating facilities, software, building governance structures into all of that of biodiversity research. Let me move a little bit faster. So EUDAT is now taking all of this combined wisdom and crystallizing it into some of the most important basic services. This sounds easy, and the process is straightforward. But still, you have to work with different communities, which very often we don't speak their language. And so it takes a while to get boiled down to the most important services in need. And certainly, this is a loop. You start with these guys, you talk to these guys, you very carefully listen to them. They put on the list of requirements, and these get digested. The result is a version 1. And with this version 1, which here, again, is something like a 12-month development, and coming out with this prototype, bringing that to the communities, get to use them, yeah, and get their feedback, and so on and so on. So that's what, yeah. And there are more communities, by the way. I almost forgot that. There are already about 10, 11 additional communities waiting in the queue to be basically included. Could be a next round of funding there. Okay, let me just summarize the basic services. Most of them we are very familiar already. I mean, in the very early 2000s, I gave a talk on grid computing when I was with Sun Microsystems. You remember maybe the cluster grid, and it was heavily disputed why we call it the cluster grid, the enterprise grid, and the global grid. Yeah? And basically all what we learned there is already in this somehow. So one of the basic services is safe replication, which is about data curation and access optimization, access to the different resources, and very close to that is data staging, which is more about dynamic replication or to the HPC workspace, where the data is needed for processing. because it is a distributed environment. Then the next one is the metadata catalog. I mean, that's a very old and proven concept to put the keywords into some very easily accessible, visible library, and then help to access the real thing. And then we have the simple store for John Doe. Yeah? Also, John Doe wants to use this. It's not only for an elite group of small group of experts, but more and more. I mean, if I have a great business idea, or I want to support something, or I want to dig into that, I would really love to use some of these community results to create my own business in the future. I mean, this will explode very soon. I mean, we almost see it already, but it's at the horizon. And finally, we have the dual A or triple AI, which is about authorization, so who is allowed to use what, authentication, yes, I am Wolfgang, and the identification thing. Yeah? Very standard, so no secrets here. And all that together is accessible through one homogeneous, nicely and common EUDAT portal. It has additional APIs into it so that you can program against it. You add your additional services, add your additional bells and whistles even within this portal, which are customizing this more standard portal then for whatever you do specific. So for the sake of time, I want to run quickly, and this, again, this presentation will be available through John & John. So we have safe replication. It's basically repeating what I just said in some nicer words. Metadata, simple store, persistent identifier, then the authentication, authorization, identification service. In addition to all these developments towards a collaborative data infrastructure, there has to be a team which operates the whole thing. Because at one point in time, we all can see a commercial service coming out of this. Yeah? Certainly, as almost everything today, it is partially free and for the most standard things, but there will be, or there might be, more enterprise-like level services. So at one point in time, you want to have a professional operations team, a team which does support, which is taking care of all the security in different layers, depending on the level of security you need to have. And then quality assurance. It's extremely important. I mean, with whatever we do today, we need to get to that level. It has been said before by Edison that, I mean, one of the most important things in getting to a broader community is by incentivizing them in the direction of quality. Yeah? So quality is a real driver for doing additional HPC simulations to get to refining of the geometry, to get to the refining of the materials you use. When it comes to crash, you need lightweight stuff, but still very safe and secure, and heavy stuff. I mean, heavy in keeping everything together, I mean, not weight-wise. So that's, quality will certainly be an even stronger and stronger driver for moving into, I mean, you need a big incentive to go from technology A today to move to technology B tomorrow. The same like, to move from your local environment to a mixed local, global, local cloud environment, for example. There has to be a big benefit, a big advantage on that. And one of those is certainly the quality. Okay, so the work plan for the next month is very clear, obviously, after what I tried to say. We want to move these services to a production environment by repeating, 2 or 3 more times this circle and cycle. Doing this, then ideally we capture some additional requirements. We improve, enhance, refine. And we will integrate definitely 5 to 10 new partners into this EUDAT community, which is basically the developer and operator. The users are sitting on the other side of the fence. This is basically the research, the different research communities. We will continue and increase the collaboration with other initiatives. There are quite a few other larger communities in Europe which mostly get funded and still face the challenge of, interoperability, it's more and more, but even more the sustainability of these infrastructures. Who pays for it in the future? Currently, Brussels pays for it, but in the future, when you have the users, are the users paying for it? And so it's still currently all in flux, especially, I can only talk about Europe. And so defining EUDAT's path to sustainability, that's what I just mentioned. And okay, so this is my last slide. And if you are interested in more and deeper stuff, the next EUDAT International Conference will be in October. The first one was in Barcelona. This one is in Rome. So here it is, and you are very welcome to join if you like to. And with that, I would like to thank you very much and hand over to John again.